Hi, so we're going to go over a couple more examples for how to solve a quadratic equation by factoring. But first, I just kind of want to explain why this top portion of the notes is there. Last semester, a student kind of asked me, they were having a hard time figuring out which method of factoring to use and when. So these notes try to go through that of how you can tell when you might need to factor using GCF versus double bubble versus trial and error, so on. So that's what that's for. And then I'll also list your first 15 perfect squares here, which we are going to be using pretty extensively throughout the rest of 1.2. I'd also like to go over with you guys this first example. I made a video and had to start over, so I'm going to work this out on this little green piece of paper here. Okay, so in this example here, one thing that you might want to notice is that we have a fraction, and the fraction has a denominator of x, and since that's the only denominator, that's going to be my LCD. And so if you recall from 1.1, when we have an equation with fractions, we first and foremost always want to try to clear the equation of all the fractions by multiplying by the LCD. So if I multiply each of these by the LCD, so multiply each of these by x, what's going to happen is I'm going to get 12x squared, I'm going to get a negative 7x, and these x's here will cancel, and I'll get equals 12. Now, if you watched the first video, you may recall that in the second example, he talked about how you have to get one side equal to 0 before trying to factor. So we actually need to move this 12 over or subtract it from itself. I always say just move it over because it almost looks like that's what you're doing since you don't have a like term on this side to combine that 12 with. So this is what we're going to attempt to factor. We do have a 12 in front of our x squared, so we do need to use trial and error. So if I start with the factors of 4 and 3 and think about making a 4 and a 3 in front of my x's here, and start listing some of the factors of 12, 6 and 2, 2 and 6, 3 and 4, 4 and 3. I'll start with those. We want a difference of 7. We want our products to make a difference of 7 somehow. So I always just think, okay, 4 times 2 is 8. 3 times 6 is 18. What's 18 minus 8? That's 10. So no way to get a difference of 7 there. This is 24. This is 6. That would subtract to make 18. This is 16, and that's 9. Okay, now we have a way to make a negative 7. If we make that a negative 16 and that a positive 9, negative 16 plus 9 makes negative 7. So that tells me where my signs go. The 4 and the 3 are the numbers in front of my x's, and this 3 and this 4 are the numbers behind my operation symbols. We have one more step, and that is to set these equal to 0 and to solve. I think you guys are pretty good at that by now, so I'll fast forward that step. So obviously for the first one, you just subtract 3 from both sides, divide by 4, you get your one answer, and similar way is how you get your other answer. So that would be example 1. Now, I'm not going to go through each of these examples because I've streamlined this assignment and taken out some of these other problems. If you want to challenge yourself and try, I strongly encourage that. Math is fun, and it's fun to see if you can do the more challenging problems by applying the principles that we learn. So we're not going to go over examples 2 or 3, but we will go over example, the try right here. And again, I'm going to have to rewrite this on a sticky note, so let me do that real quick. Okay, so something unique about this problem versus others that you may have seen like it is that this last denominator is not factored. And it can be. So we want to start with that first. We want to try and factor that. So we put an x here, factors of 3 that give me a difference of 2. Well, that's going to be negative 3 and positive 1. Quite a coincidence, right? Like these other ones are x minus 3 and x plus 1. It usually works out that way. So that tells me what our LCD is going to be. It's going to be x minus 3, x plus 1. And like in 1.1, I kind of encourage you guys to think about this mentally. Like if I were to write this whole thing and write times and put that whole thing there, you know, I know that the x minus 3 in the LCD would cancel with the x minus 3 in the denominator, and I would be left with x times x plus 1. So basically whatever's missing from the denominator is what you end up multiplying by the numerator. So in this case, I'd multiply 3 by x minus 3. And then for the last fraction, the whole denominator would cancel with the whole LCD, and I would be left with 11x minus 1. Okay, so now we want to distribute. So we get x squared plus 3x minus 9 equals 11x minus 1. We want to combine like terms. So we get x squared plus 4x minus 9 equals 11x minus 1. We want to cancel one side so that it's 0, and whatever we do to one side, we do to the other. So I'm going to subtract 11x from itself and 11x from 4x, since those are like terms, and do something similar with that 1. And now I have 0 on the right, and on the left I have x squared minus 7x minus 8. And now what I'd like to do is factor, and this factors as x minus 8, x plus 1. Set those factors equal to 0 and solve for x, and you end up with x is 8 and x is negative 1.